All right, so the next type of diode is, this comes under the category of optical diodes. Uh, One of such diode is LED, called as the light emitting diode. Again, when we say the term optical diodes, there are wide ranges of optical diodes exist. So optics referring to the light. So optical diodes means that the behavior of this diode depends on the light. Whether they're going to emit the light, that means whether they're going to generate the light. Under that category is the light emitting diode. So it's a diode, it will emit the light of different colors. So you can have a green LED. So these are the ones you usually see when you're turning on a computer. You usually see like a green light on the push button. So that's an LED. All the traffic lights are LEDs, but there are array of LEDs. There are group of LEDs, especially those are high power LEDs. So, but those are the light emitting diodes. It works in the same way like a traditional diode. So when you forward bias the LED, electron cross the PN junction and then recombine it. So it's the same process like a traditional diodes. But the amount of the type of material that is used for doping and generation of these LEDs, depending upon what type of material it is, that recombination will provide you a visible light. So if you have a red color LED, then the type of doping would be different than a green color LED and so on and so forth. So in a traditional diode, when you have a recombination, current will be allowed through the diode. So in this case as well, when you have electrons and holes crossing the junction, then you're going to have some current, but that recombination will provide you photons. Photons is basically like electrons, but it's a term that we use in order to reference the particles for the light. So electrons are used for referencing the flow of current in electric field. Similarly, photons is a term we refer. It's very similar to like an electrons, but that's from the light perspective. Yes. The LEDs, most of the LEDs you will see are monochromatic, meaning that it's a single color LEDs. But now you have a multicolor LEDs which can be programmed using a processor. So like the color changing LEDs. So you might see in some gaming computers, you might have like a keyboard changes to different colors. If you ever see that, those are like a one LED, but you can program it to generate different colors from it. So those are multicolor LEDs. So the symbol for LED is like this. Most importantly, you see these two arrows are going outside. That implying that this diode is a LED which is emitting the light. That's why those arrows are pointing outside. Another major difference with the traditional diodes, remember that traditional diodes requires at least of like 0.7, correct? So, but LED breakover voltage can be anywhere in that value, depending upon what color of the light the LED is emitting. So some red color LEDs, they may lit when you are at 1.2. But if you use like a green or orange color LED, you may need a little bit higher voltage. So the LED diodes will have a forward voltage which is usually higher than traditional 0.7 volts. So you need like 3 volts to properly bias these LEDs, depending upon again the color of the LEDs. And you can break these LEDs very easily. You can damage them very easily under reverse bias. That's why we need to be very careful in using these LEDs. Traditional diodes, their breakdown voltage is like 50 volts, 100 volts. It's very hard to damage like something like those. But these LEDs you can damage even if you put like 3 to 10 volts under reverse bias, you can damage quite easily. And these are also used in 7-segment displays. If you want to know, if you remember, like for example, when you're walking on a street, like the pedestrian crossing, right? Correct. So if you think about the pedestrian crossing, so you push a button, you see a timer that goes down or goes down mostly, correct? So that's another type of LED. So the shape looks like this, like probably like 2 digits, right? So if you think about that application, so for example, if you count, I have 7 lines in here. Each line in here is an LED that will be lighting. So for example, if I light this, what number I was forming? That's a 7. Let's say if I light these LEDs, that's a 2, correct? This is also same method that you see on your multimeters, not on the LVS, but the actual multimeters. If you have it, you can take a look at on your multimeter. You can kind of see exactly the same pattern. Yeah, that when all the LEDs light up, then it would look like an 8. Yeah, 7-segment means there are 7 LEDs going to be in there. Yeah. The DMM in front of you, you see each digit visible to you. Oh, yeah. So if you turn it on, you will see only some will light up. Yeah. So this is also the same one that you see when you're crossing for the pedestrian crossing, where the number goes down for counting. So that's a 7-segment display. That's basically controlled by a processor on what type of numbers that it should show. But each line in here is an LED as well. So, but again, depends on the color. Mostly, I think red color is what you see. Yeah. And there are some LEDs you cannot see the light. For example, all these are visible, like where we can see it. But there are some lights which are IR. So what is that IR for? It's an infrared. So infrared LEDs, this is the light that we basically not visible to the human eyes. It has a wavelength or frequency extremely high. But where do we use this? Yeah, low light are also in the remote control. That's the one example that you see when you're turning on off TV or whatever the remote that you will be using. If you observe in front of that remote, you will see an LED that's usually shaped like this part that you will see it. But this is basically powered up internally with some sort of triggering circuit. And if you ever use your like if you have an Xbox or something, you see Xbox has a camera that's called as a Kinect. If you ever use that, Kinect also has a group of IR LEDs, but you cannot really see it. It's usually used for tracking the objects. like you send the signal. So mostly these IRs are basically, so the LED will send a signal. What? You cannot see visually. It's not visible to your eyes, but an instrument can catch it. There are instruments that are used to design this, to use it. Right. So you cannot see when you get a phone call, right? So so
I have a question with LEDs. So like, don't you know like the little trip wires like in the movies, people are like breaking in and they got like security.
yeah, that's an infrared.
That's infrared. Yeah, yeah.
That's another application is the security for the infrared. So when you break the beam, like for example, in such applications, even uh, when you have a garage door, so on the garage doors, if you place an object under the garage door, if the door is trying to close, usually it will stop before if there is an object. So what usually these have is a sensor housing on one side. Let's say we call this as a transmitter. And all the way on the other side, we're going to have another sensor that's usually a receiver. So this transmitter sends signal directly. So usually these two are aligned at line of sight, meaning that their height pattern should be exactly equal. Meaning if there is no object in between, the receiver will receive the light. So that means nothing is right there. But if an object comes by that breaks that beam, then we can design a circuit on the other side to do whatever the required action. So that deals with the programming, external circuitry. But this one is an IR transmitter, and that's an IR receiver. It's heavily used in the manufacturing industry as well. If you use multiple IRs, you can create what is known as a light curtain. So for example, if you have a heavy machinery that is operating, if somebody try to reach, then it will disconnect the entire supply to that machine for safety. So
That's what they use in
manufacturing.
robots. They can engine walking around. You really, if you step in front, it wouldn't even slow down. Without that, it can increase.
So yeah, there are a lot of applications to these. Some of these applications, in fact, you will learn some of these down the line. Probably build some applications with it. But there is a course where you will use infrared exactly like this actually, position them opposite to one another. But depending upon how much power you are transmitting, the distance will depend on it. So how close you need to place them. Based on that, this is also an optical diode. But this one, you can look at by its symbol. It works when light falls on the diode. This is like the solar cells. They won't emit the light. They're not going to generate the light, but when the light falls on the diode, then the diode will conduct. Again, it is designed to operate under reverse bias condition. Usually these diodes have a transparent window on the top where the light can shine inside onto the material. So these are like solar cells. So what happens is when light strikes, then when you are under reverse bias, then the current will be generated through the circuit, which is usually depending upon what is the source that we are using. This is like the infrared receiver inside your TV. So for example, when you're changing the channel on the remote, you have an infrared transmitter. But inside the TV, you're going to have an infrared receiver. So this LED is like the receiving side of it. Yeah, both are the same. As long as the arrow is pointing inwards, that indicates it's a photodiode. Yeah, so the LED, if you look at LED, for LED is the arrow is pointing outside. So that means this is going to generate the light as opposed to receiving the light. That's usually like a lens, like a transparent material where the light can shine on that. It's like a lens in the camera. So that's a photodiode. It's a very similar to the infrared, but that's like a receiving side. So this one is like a receiving side of it. Again, that's just an arrow. So you can use either this arrow, that arrow, it doesn't matter. As long as the arrow is pointing down onto the diode. But when the arrow is pointing up, it's emitting the light. If it is down, it's receiving the light. So this shows just the same operation. So you can see that it just shows you when the light is on, when light falls onto the diode, you see there is some current. When there is no light, then there is going to be extremely small current. This is also, if you think about automatic headlights in a car, right? So that means when you're going through a tunnel or when it is dark outside, the lights will come on automatically. When you put your headlights into the auto mode, if you have that feature, it's basically diodes responsible is a photodiodes. That's a humidity sensor. So for the windshield wipers, if they're turning on automatically or changing their speed without you actually touching it, that's a humidity sensor that detects the moisture in the air and can predict whether it's going to be rain or how hot is it. This is depends on what type of it is. Mostly it's an IR. Mostly photodiodes that you'll see is an IR. Yeah. Yeah, it's possible. There are some photodiodes that can accept red, green, different types of color. Depends on their wavelengths must be matching. So what is called as it's a wavelength. So the wavelengths must be matching. For example, remember previously I have transmitter and receiver. I cannot have any type of IR transmitter and I cannot have any type of IR receiver. There is something called as a wavelength in nanometers. So that wavelength should be in the range. For example, if the transmitter has 800 nanometers wavelength, if the receiver is designed for capturing 1000 nanometers, it's not going to work. Yeah. For example, also the barcode scanners that emits the light, correct? That's also LEDs. So when you actually look at the scanner, you will see a group of LEDs, not a one LED, but either it's a red scanner or a green. I think mostly you see red, but green is also used. And another application of infrared is if you have a smart watch that can detect your heartbeat, that's an infrared. If you are that's an infrared. You don't see infrared. So you don't see infrared. So it's usually 2 to 3 LEDs. Yeah. Because you see only the green. The other one you don't see it. So it's a combination. Yeah. Because it's depending upon the thickness of your skin. So if you're designing a product, they usually design for most of the people like thicker skin, thin. Some can penetrate, some don't penetrate. And also the bloodstream inside, the signal has to reflect. So for example, if you have a very thick skin and if your hand is very thick, then your blood vessels are usually right all the way down, not here. So they used to in the depth, and it will gives you if you this is only you will see when you are in the hospital probably. Uh, the heartbeat will go something like this, right? So the distance between these two is a time period. You can find the frequency. Remember, frequency is 1 over time. So that means if these two peaks are closer, your frequency is higher. That means your heartbeat is higher. Like traditional heartbeat is what, 76, something like that. Depends on what age you fall into. So that means you will see it's like 76 of these in 1 second. In 1 minute, sorry. Yeah. 76 beats per minute. So you see BPM. Yeah. And also it's the same technique that you see when they check your heart rate. They use a clip onto the finger when you are in the hospital. When they put that clip, that's an infrared too. It's the same technique that's used. So